A rectangular storage container is designed to have an open top and a square base. So I have an X and an X, a height for my box, and the top is open. The base that has side length X and a height of H, the sum of its dimensions, the sum of the length, width and height, is 48 centimeters. So given, I'm just going to write here given, is that length plus width plus height equals 48. In other words, X plus H equals 48. In other words, H plus 2X equals 48. So that is by giving information. Let's go and see what they ask. Question A, they say, express H in terms of X. So it means that I have to say H equals something in terms of X. So make H the subject of my formula. So for A, what I'm going to do is I already have H plus 2X equals 48. Subtract 2X from both sides. So H will equal negative 2X plus 48. So that is my first, that's question A. I've now said H equals minus 2X plus 48. Remember, that's the same as 48 take away 2X. Just want to look a little bit neater. Right, question number B. They say show that the volume of the container is given by V equals 48x squared minus 2x cubed. Now, what do I know about the volume of a cuboid? Well, I'm going to say this is length times width times height, which means I don't have length. The length is x. So the length is x. The width is x, so that's times x. And then I also have the height. But if I look at what they've given me here, so they say prove that there's no height there. But I have height. The height here is the same as the height here, and that's already in terms of x. So I can substitute this h with this h. Okay, and that will give me then the volume equals x times x, so that will be 48 minus 2x. So this will give me x squared times 48 minus 2x, and that's the same as, well, that is the same, multiply out or expand the bracket, that will give me 48x squared minus 2x cubed, exactly like what I have there. In my C question, they say state any restrictions on the value x can take. So what do we know about x? If I go back to what I have here, x cannot be 0. So x must be greater or equal to 0, although it should just be greater than 0. So x should be greater than 0, and the height should be greater than 0 as well. And what is the height? The height is 48 minus 2x, which means 48 minus 2x must also be greater than 0. Now I'm going to subtract 48 on both sides, so minus 2x is greater than equal than negative 48. I'm going to divide by negative 2 on both sides. Now please remember the following. The textbook made a mistake here. It says divide by negative 2, divide by negative 2. The moment I divide or multiply by a negative, my inequality sign changed. So this becomes x is less than negative divided by negative is positive. 48 divided by 2 is 24. So x must be greater than 0 and x must be less than 24. It can be 0 or it can be equal to, but then there's no volume. So what's my restriction? 0 is less or equal than x, less and equal than 24. So that is my restrictions for x. Let's go to D. They say sketch the graph of v against x. So v in terms of x, so they're asking us in D to draw the graph. Remember, this is still v. So they say draw this graph. V in terms of x. Okay, so I'm going to draw that graph. And I'm only going to draw it for the restraint, so only until where x equals 24. Now, to draw this graph, it's an x cube graph, okay? So my y-intercept, let's call this now, remember, I'm going to have, I just quickly want to draw you a graph. We'll have to move it a little bit smaller. So we're going to draw a graph that looks like this. X can't be bigger and smaller than 0, so this must be 0, and the biggest it can be is 24. My x-intercept is where y-intercept is where x equals 0. If x is 0, then y, which is my v value, this is v, is y. So probably have to change that quickly. This is v. So v-intercept, v equals where x is greater than 0, v equals 0, because anything times 0 is 0. Okay, so v is 0, I know it goes through there. And my x-intercepts is, where y equals 0, or where v equals 0. There we go again. Where v equals 0. If v equals 0, then 48x, we've already done that, x squared, 48 minus 2x equals 0, which means x squared is 0, or 48 minus 2x equals 0, which means x is 0, or x equals 24. So my graph is going to look like this, and it would have looked like this if I carried on the other side. So this is how my graph will look like. They say sketch it if we know that the maximum is 16. So that is 16, the maximum is 16. And the y, the volume is 4096. Those values I got from my That 16 and 4096 comes from my equation. Now they say calculate the dimensions of the container with the greatest possible volume. Now they said that 4096 is the highest value for my volume. So all I have to do in E is say, right, what is x? Sorry, I'm jumping around, but it's the only place I have. Let's do it in another color. Let's go to green. I'm going to say E equals, what I have is I've got the volume. The volume is where x equals 16. So what is my height? My height will be 48 minus 2 times when x is 16. That gives me 48 minus 32 is 12. No, it's not. It's 16. Undo. It's 16. So the height will be 16 centimeters. It will be the same as the width. So what's my dimensions? The dimensions of the container will be 16 by 16 by 16 centimeters.